You know, in the world of artificial intelligence, there is an absolute war raging. But it's not a war of algorithms. Nope, it's a bare-knuckle brawl over the hardware that makes it all possible. Today, we're going to break down this high-stakes battle for AI supremacy.
So, in this AI gold rush we're all living through, one company has been selling pretty much all the shovels and pickaxes. NVIDIA. They are the undisputed king. But a really powerful new challenger has just stepped into the ring, and they're looking to shake the whole industry up. Okay, let's get right into it. The best way to think about this is like a championship boxing match. In one corner, you've got the reigning, undefeated champion, and in the other, a hungry new challenger. The prize? Well, it's pretty much the entire future of artificial intelligence.
So let's meet our fighters. First up, representing the champion, we have the NVIDIA H100. This is the industry's go-to chip, the one everybody wants, and it's backed by this legendary software ecosystem called CUDA, which, it's basically the language that every single AI developer speaks. And then, the challenger, the AMD MI300X. This thing is a beast, with some specs on paper that are, well, they're absolutely staggering.
So for round one, we're going to look at the tail of the tape, the raw theoretical hardware specs. And right out of the gate, this is where the challenger comes out swinging, and man, do they look incredibly strong.
What's really fascinating here is this raw power metric called TFOPS. Just think of it as how many trillions of calculations a chip can do every second. These formats you're seeing, like FP8, they're all about low-precision math. It's less exact, but way, way faster, which is perfect for AI. And would you look at that? In these key areas, the MI300X has a theoretical power that's just way higher than the H100. On paper, this looks like a knockout punch.
And the challenger's strength isn't just in raw number crunching. Think of memory bandwidth kind of like the width of a highway. The wider it is, the more data can flow through at once. For these huge AI models, that's absolutely critical. And here again, the MI300X is showing a massive theoretical lead. Its data highway is just wider.
Okay, so the specs look incredible for AMD. It seems like a clear win, right? But theory is one thing. Reality can be something else entirely. It's time for round two. What actually happens when these chips face real-world tests?
And this chart right here, perfectly illustrates the central mystery of this whole story. The orange bars, that's the massive theoretical power we just talked about. The blue bars, that's what the chips actually deliver when you test them. Just look at that massive gap for AMD's MI300X.
So let's put a number to that. This is the crucial point. According to some recent research, AMD's MI300X only achieves, on average, about 45% of its peak theoretical performance. Meanwhile, NVIDIA's H100 sustains up to 93%. I mean, that's just a gigantic difference in efficiency.
And here's the bottom line for anyone who's actually trying to run these AI models. Even with those amazing specs on paper, when you put it to work in the real world, the MI300X is significantly slower. It delivers as little as 37% of the H100's performance.
So this leads us to the billion-dollar question, right? How can a chip that has so much raw power underdeliver so dramatically? What is going on here? Why is there this huge disconnect between the specs and what actually happens?
Well, the answer isn't in the silicon, it's in the software. And that brings us to round three, where we uncover NVIDIA's secret weapon, this invisible but incredibly powerful software moat.
So, a software moat is this idea that a company's software is so dominant, it basically builds a giant wall around their business that's almost impossible for competitors to get over. And for nearly 20 years, NVIDIA has been building its CUDA platform, and it has become the absolute bedrock of the entire AI industry.
Now, AMD isn't just sitting around, of course. They are actively trying to build an alternative. It's an open-source platform called ROCm. The whole goal here is to build a bridge so that developers can cross from NVIDIA's walled garden over to AMD's hardware.
But the challenge they're facing is just immense. As one developer on Reddit put it so perfectly, because every machine learning library is written with CUDA in mind. And that quote, it just gets right to the heart of the problem. The entire world of AI development thinks in CUDA.
And this creates that classic chicken and egg problem, right? All the important AI tools, they get built for CUDA first. So that means all the developers are invested in using CUDA. And with everyone using CUDA, there's not much incentive for anyone to spend time optimizing things for AMD's ROCm. It leaves AMD's software just constantly, perpetually playing catch-up.
But what if the very technology at the heart of this war, AI itself, could completely change the rules of the game? This brings us to a really fascinating new development, a potential wildcard that could just disrupt this whole dynamic.
This is where things get really wild. A developer recently shared this mind-blowing experiment. They used an AI agent to translate a complex program from NVIDIA's CUDA over to AMD's ROCm. And the truly shocking part? It took 30 minutes. 30! With no manual coding, no clunky translation tools, just done.
And this wasn't some niche thing nobody noticed. Oh no. The industry took notice. AMD's own vice president of software came out and declared the future of GPU programming belongs to AI agents. That shows you just how seriously the major players are taking this possibility.
And this is basically how it works. Instead of a human having to manually rewrite thousands of lines of code, the whole process just becomes simple. You feed the AI the original CUDA code, the AI agent figures out the logic, and boom, it spits out new, optimized code for AMD's hardware.
The implication here is absolutely profound. I mean, what if the biggest barrier to hardware competition, that giant software moat, could be dismantled by AI itself? This could finally level the playing field and let the best hardware win on its own merits, not just because of its software.
Which leaves us with this final, really critical question. For decades, the mantra in tech has always been software is king. But in the age of AI, you have to ask, will that always be true? Or is AI about to become the ultimate kingmaker, breaking crowns and totally reshaping the entire tech landscape?